All right, hi everyone. This is Levent Gurdemir of UTA Planetarium, the Planetarium Director, and I'm here with you again with another live streamed Planetarium show. And today's great topic is going to be the moon. And why do we care about the moon? Well, sorry, we are 2 minutes late to our live stream because we were working on some technical difficulty, and it seems like our wireless is being upgraded in the building. So I hope we will have a uninterrupted 30 minutes with you. So let's go back to the topic. Why do we care about the moon? Well, we care about the moon because it is the brightest and largest object in the night sky. It is the only place beyond Earth that humans set on foot. Moon is far away. Well, depending on the scale we are talking about in the universe, it is about 240,000 miles away from Earth. So this distance is equivalent if you go around Earth about 10 times. You get that type of distance. Moon is small. Its diameter is only 2,000 miles. So if we bring Moon and put it on the map of the United States, it is between about San Francisco to Chicago. So it is not even covering the entire the United States. On the screen, sometimes you see that the representations on the moon and Earth system, like the one above, this is a misrepresentation because if you put the moon and Earth in scale, they are not actually looking that great. So actually the bottom representation is the scientifically correct representation, not an amazing representation as you can see, but the moon, the relative size of the moon and Earth is very small. The moon is very small and moon is pretty far away if we make it scientifically accurate. So the moon covers about the same area in the sky as the sun does. Well, there is a significant brightest difference. We are not talking about that, but because they are covering the same area, that means when there is a great alignment of the sun, moon, and Earth, that sets the stage for solar eclipses, which is great. Well, in the next few years, we are going to have a great total eclipse here in Dallas-Fort Worth area. But still, it doesn't address the importance for our daily lives. Is the moon really important for our daily lives? Well, sort of. Maybe you can decide after I list a few reasons why it may be important for us. First of all, the moon has a great gravitational influence on the Earth's rotation axis. As you know, the Earth's rotation axis is tilted towards the sun by about 23 degrees, and that is the main reason for seasons. The moon's gravitational influence is actually providing anchor, a great anchor for this rotation axis, so it doesn't fluctuate much. If the moon didn't exist, the rotation axis would fluctuate at a greater degree. So what would happen if it fluctuates? Well, we could go to the ice age, cold, to extreme heat within 10,000 years. And that is not a problem for somebody who was born in 1990 and that lives now, but that's going to be a problem for the humanity or all the species on Earth. Moon has 4 basic phases. When we don't see it in the night sky, we call it new moon. And then after roughly about a week, it gets to a first quarter phase, then full moon, then second quarter. Between the new moon and full moon, illumination of the moon increases, that we call it waxing. From the full moon to new, it wanes. If you heard the term harvest moon, It is the name of the full moon that appears around the autumnal equinox, which is September 23. The term harvest comes from because it's the time that farmers work after sunset using the full moon's light. So apparently that's important for farmers. The phase of the moon is important for planting. The Farmer's Almanac explains when to plant gardens for best results. So how come can the moon or moon phase be important for planting? Because there's actually complex science behind it. But just for the short fact, during full moon, there are tides, the ocean tides, and these similar tides bring the underground water to the surface level. So that is beneficial for the products. The full moon is also important for ecosystem. So biologists can talk about it for hours, but some animals use full moons to migrate, hunt, and feed. Sea turtles, for example, lay their eggs during full moon, and whole sea ecosystem is in great rhythm with the moon's phases. There is another fact. Moon's gravity pull the water from oceans at a higher tide that creates a friction between the seafloor and the rotating Earth beneath it. So that friction slows down the Earth's rotation rates. So that's why we have about 24-hour days. If the moon didn't exist, if that braking mechanism didn't exist, so the scientist estimates that by now our days would be 12 hours or shorter. Well, there would be more than 1,000 days in a calendar year. And the sleep cycles, how they would be affected, well, probably we would be spending a big portion of a day sleeping and the next day completely working, and etc. So those are the basic facts. The list goes on, by the way. If the moon didn't exist, there may be some other consequences. But I think this summarizes it very well. And the main question is, from the scientific point of view, how the moon got there in the first place. Because we know from the solar system, not every planet has a moon. So how did it get there can be explained by some theories, and some theories are more, make sense more than some other theories. And the commonly most accepted theory is about 44.5 billion years ago, so that is short after the formation of the solar system, the moon, the Earth was collided with a Mars-sized body, another planet. So this collision extracted moon-sized mass from Earth, and first that type of mass should be in a debris form and orbiting around Earth and then forms in a moon. So that is the best theory. Well, that theory has some strengths and some weaknesses. For example, we cannot really explain after the debris disk how this debris disk turned into a moon-sized moon. By the way, we call it moon. I forgot to mention the moon doesn't have a name. We call it the moon. And the reason for that is until 1610, we did not know other moons exist. So we just called it the moon. And after Galileo discovered other moons around Jupiter and then later some on the other planets, we named other moons. But our moon, the original moon, remained as the moon. So it doesn't have a name. But yeah, let's go back to the topic. We cannot explain completely how this debris disk turned into a moon-sized moon. Also, the collision should create a molten rocky region on Earth. So this is another the weak theory. And also, when we look at Venus, probably the similar collisions in the early solar system happen to Venus too. And why Venus doesn't have a moon? We come up with some other theories, some other patch theories for that. That's something we cannot scientifically prove because we don't have any evidence. But maybe Venus formed another moon, but there was another collision that knocked out those newly formed moons out of the orbit of Venus. So there are theories, but those are all theories. And it is not easy to prove 100%, but we stick with the most making sense one. Well, the moon orbits around Earth, and the orbit is actually pretty interesting. It is in highly eccentric orbit. That's why we have a close side when the moon gets close, relatively close and relatively far, because the shape of the orbit is not a perfect circle. So on another video, we will address the supermoon issue. I call it issue because I really have an issue with the term supermoon, personally. And the rotation. The moon rotates around its axis like any other planet and Earth. But the rotation, there is a good synchrony on the orbit of the moon and the rotation of the moon. So when it orbits around Earth, it is turning its face just enough that always the same side of the moon faces Earth. Well, what happens to the other side? Well, we call it dark side, not because it is dark all the time, because there are times what we call dark side of the moon is actually well lit by the sun during new moon phase, for example. But we call it dark side because we don't have visual information about the backside of the moon. Of course, our space rovers and orbiters went around the moon and took fantastic pictures and video. And what we realized, the other side of the moon, what we call dark side, is that it has more craters than the side we see it. The reason is, we should maybe ask that question as a for a free ticket or something like that to our audience. But let me answer this one. This is actually a very interesting question. Why the dark side of the moon has more craters and it's not as smooth as the near side? Well, the reason is the moon is still under the attack of asteroids. There are a lot of asteroids in the around Earth and moon system. They fly freely, and moon doesn't have air. Earth does. Well, when the Earth encounters an asteroid's attack, what happens is it burns and it makes a trail in the sky. We call it shooting star in public, meteor in science. But the moon doesn't have any air, cannot burn anything, and they go straight through the surface of the moon, hit, plunge, and create a nice crater. So when that happens, the craters are being added to the backside of the moon. Well, the near side, because it is facing Earth, it is highly unlikely that an asteroid will come and hit to the near side. Well, still can happen, but the probability is more for the other side. So on the surface, when we look through our telescopes, we see a lot of nice features. It is one of the great star party, the star party object. You go to star parties, and if the moon is not, if the moon is up in the sky, the first thing probably they will show you is the craters on the moon. We cannot, however, regardless how big the telescope you are using it, from the ground-based telescopes, we cannot see the rover and all other artifacts left on the moon's surface by the astronauts. Well, we cannot see them because they are so small in size, so no telescope on Earth can resolve these artifacts. However, there were previous moon missions. They actually did flybys to the moon's surface, and they did take pictures of some of the things that astronauts left on the moon. Those were the car they used on the moon's surface, and also their launch pad. Well, they cannot bring the launch pad with them because actually the lander carried like a portable small version of launch pad with it. So that launch pad landed on they'd sit it on the moon's surface. It was part of the lander, and when they launched back, they left that the launch pad over there, and it is still on the surface of the moon. Well, if you ever get a chance to get close and maybe like some space exploration vehicle, feature vehicle, if you get close, maybe you can see those by yourself. And finally, I would like to mention that the moon is leaving us. Not at a great rate, so we are not gonna see the moons leave in our lifetime. We don't need to worry about that, but 1 inch every year, the moon gets farther and farther. So maybe next time you look at the moon, we can wave, but sometime in the very far future, the moon will actually no longer bound by the Earth's gravity and leave. And this is typical. This is this is happening in the star systems all the time. Well, after this video, I hope you enjoyed it. If you would like us to cover more topics like that, drop us some feedback, or if you have any questions about this video and the moon in particular, just drop a feedback and we'll get back and answer it with you. But for today, that's all. And like always, join our social media channels, Facebook and YouTube, Instagram. Find us and follow us. We will come up with more videos and more live public shows in addition to our weekly Sky Talk videos every week. So bear with us and we'll be here with you next week. Bye-bye.